being able to split up every single little part. How will we look at that? How will it be measured? And how will we look at changing health through the generations and going beyond some of the more narrow aspects that were the major focus in the MDGs? So, I don't have much time to tell you about March. There are reports here, and our focus is on adolescents, births, and children. But tonight, we're co-hosting with people who look very much at the other end of your lifespan, the later years. So the co-host in the London School here is the Centre for Communicable Diseases, and Neil Pearce will be speaking later. And also from UCL and the centre, the MRC Centre for Lifelong Health, and we'll be hearing from Professor Diana Kuh later on. So in this 90 minutes, we're going to cover a look at low and middle income countries and high income countries. Cohort studies that maybe have focused on the early years, what we're learning about the later years. What are the commonalities? What are the differences? And how do we think about that influence both for science and interventions and new studies in the future? And so, first of all, I'm going to welcome to the podium Professor Cesar Victora, Professor of Epidemiology at Pelotas University in Brazil, probably the leading light, not just in Latin America, but in much of the world for cohort epidemiology with that focus on the early years. Very proud to say that he is an honorary professor at the London School. He did his PhD here in the early 80s. And I don't often get to see him in a tie. He's even wearing a London School tie. After he left the London School, he set up a cohort in Pelotas with 6,000 children that are still being followed through. What has he learnt? What can we learn from that? And then around a decade ago, he got funding from the London School and set up a group of from the Wellcome Trust, and set up a group of cohorts that he very cleverly managed to develop the acronym Cohort for his cohorts. And you'll have to follow his talk very carefully to work out how he managed to wrangle that acronym out. Obviously a professor of acronyms as well. And importantly too, he's also a leader in building global epidemiology. He's been the past president of the International Epidemiological Society. And very importantly, he's been a founding member and a leader all the way through the Countdown to 2015 movement, so linking that data to action, particularly in the field of equity and what we do to address that. So I welcome to the podium Cesar. Thank you so much.
I was going to start by making a comment about my tie. That Joy sort of broke the news. This is I bought this in 1983 when I was leaving the school, and I said, I don't know how much I learned here, but I have to take some kind of souvenir. So this is where I got this tie, and this is the third time I wear it in 30-something years. So thank you very much, Joy. It's a real pleasure to be here, and I'm going to talk to you a bit about the past and the present in our cohort, and a little bit about the future. Here we go. If you look at births in the world, this is where they are. But if you look at birth cohort studies, this is where they are. And this is what has motivated us. Oh, it's not presenting. Okay, back. Okay. If you look at births in the world, this is where they're concentrated: Sub-Saharan Africa and South Asia and China. And birth cohorts are concentrated here. Look at the size of Finland. Look at look at England, you know, and there are very, very few cohorts in the places where most births occur. So this is what has motivated us to start and continue birth cohorts. And I'm going to talk about our own cohorts. I'm going to talk about why do we need cohorts from low and middle income countries. I'm going to talk about the cohorts network that Joy just mentioned as well, and also highlight some recent findings and the future that is ahead of us. Pelotas, when we started studying Pelotas, that's where I was born really close to Pelotas, and I was already working there when I came for my PhD at the school. It's in the extreme south of Brazil. When I started studying, the infant mortality rate was 36 per thousand. Now it's 10 or even below, so there's been a lot of change. And people have changed, and technology has changed. And there have been lots of transitions. We had a nutrition transition. We had transitions in morbidity and mortality. There's less physical activity now. Leisure patterns are completely different. Several behaviors are quite different. But also there have been very substantial improvements in my country in terms of healthcare, education, water sanitation, nutrition of children, and so on. So it's a very dynamic period that these cohorts went through. And we have just started our fourth cohort now. We started one in '82. And I actually was here in London, and my colleague Fernando Barros started the cohort because both of us were supervised by a guy called Patrick Vaughan. Patrick couldn't be here today. He lives in England, but he lives outside London. And he was really supportive of both of us. So Fernando started the cohort. I helped him with the questionnaire and the design and so on. And when I came back at the end of '83, we kept the cohort going together. We were trying to start one every 10 years. So in 1992, we were asking for support from the EEC for a grant, and the grant took 1 year more to come. So we could only start it in '93. And that's the only reason why we have 11 years from one cohort to another. We're very proud of our follow-up rates. At 30 years of age, we have examined 68% of the cohort. 20 years of age in the '93 cohort, we have 81%. We have 90% of 2004 cohort. And as I said, we just started the 2015 cohort. There's one difference from the 2015 cohort from the rest, is that we are recruiting women in pregnancy. When they first show up for antenatal care, they are recruited into the study. So the other cohorts started at birth. They're all population-based. They all include every birth in the city of Pelotas. And this is what we looked like. This guy with lots of hair here on top is myself. Fernando's at the bottom. We only had one computer, so we had to, we had the first ever microcomputer in the whole University of Pelotas. And we got that with a grant from the then ODA, which is now DFID. And as you can see, it's a 3D computer. The screen is like this, but it also has depth. And we had one office, and this is where all the field workers met. Everything was on paper. And we went to the homes of the kids to do the examinations. And this is the sort of thing we did. We'd interview people at home. One of the big things about Pelotas, and if you look at these two families, you can see that there are a huge equity gap in Brazil at that stage. Things are actually much better now, but at that stage we had ethnic group gaps, we had socioeconomic gaps, and we had water and sanitation conditions and nutrition that was very, very different. So within a single city with 5,914 kids who were born and belong to our cohort, we have a huge diversity. And this is me. I actually did field work on those days. Now I just sit in front of a computer. And this is our first questionnaire. We got the longest piece of paper we could get. It was about this long. And it was front and back. We didn't have that much money. And it had to have 80 columns because we were using punch cards. So we really got a lot of mileage out of 80 columns because that's all we ever had at birth. We didn't take any samples. We had just one questionnaire. And then we followed up this cohort on a number of occasions. Not very well organized. Now we're much better because now we can attract more funding. But we actually followed them up at 1 year of age. We had a sample. We didn't have money for the whole cohort. Then we got everybody at 2 years, at 4 years. And then we stopped. We thought, our cohort has finished. Let's do other things. Let's do case control studies. Let's do other things. And then at 15 years of age, we said, let's go back. And then we got them as adolescents, and then 18 years, 23, and now 30 years of age. So it was a bit random, the ages in which we did the measurements. The second and third cohort we were able to do it in a much more well-organized way. Now, this is what we have now. We have these two buildings. They are next to each other. The one on the left is classrooms and our offices, and this one on the right in the bottom is just for the cohorts. It's just for examining the cohorts people. And we have all sorts of high-tech equipment now. It's hard to believe how different things are from those days in which we actually went from home to home in every town of every house of the city to collect information. So here's what we have now. We have labs, we have GWAS, we have all sorts of body composition equipment. I really like this piece here, this one here. This is a 3D scanner. We don't do anthropometry anymore. We get a 3D computerized image of everybody, and then we can take any measure we want in the computer. So it's a big change over time. Well, our cohorts are all population-based. They included all hospital births in a calendar year. Birth rate is going down, so our new cohort is going to have 4,500 kids maybe. The first one has 6,000. We had different ages of the visits, and since 2010, they come to our clinic rather than we go into their homes. And we have multiple outcomes. I mean, we can't afford to have a cohort in a low and middle income country, or even in a high income country, I think, that is highly specialized. It's such a great opportunity that we can, and I'm sure we're going to get the same message from the British cohorts, that you look at mortality, morbidity, growth, nutrition. We look at psychology, mental health, human capital. We look at the next generation, and so on. So they're all multi-purpose, multidisciplinary teams working in the cohorts. Now, why do we need cohorts from low and middle income countries? First, because most cohorts are not from low and middle income countries, so we need two prospective cohorts that are uniquely suited for studying early determinants. And the results from high income countries may differ from those from low and middle income countries in terms of the frequency of exposures. We have a lot more low birth weight, very high preterm birth rate. There are different natures of exposures, and also there are different confounding factors. You know, cohorts are observational, so we have to worry a lot about confounding. And therefore, I just wanted to give you one example. Here are some cohorts from, this is one in the top one is from Philippines. You see the breastfeeding is higher in the poor than in the rich. If you look at the blue line, that's Ausbach from Bristol. Its breastfeed is higher in the rich than the poor. Pelotas is just about very flat here. And this is a great advantage for us because we do a lot of studies on breastfeeding, and we don't have to worry as much about social patterning of breastfeeding and residual confounding because the confounding goes in different ways. The top one shows that in a high-income country, if you're rich, you breastfeed longer than if you're poor. If you're rich, you tend to be more intelligent, and therefore you have confounding, a positive confounding here. If you go to a lower middle-income countries, in most places, if you're rich, you're less likely to breastfeed. So the confounding goes in the opposite direction. And we can learn a lot from comparing results from different cohorts. As I said, in Pelotas, we're somewhere in the middle. We don't really have a clear social pattern of breastfeeding, which is actually very good. And I'm going to show you some results at the very end. What are the other reasons for having cohorts in low and middle income countries? We have different starting points from growth. So the results I'm going to show you later, you have to think those kids that I'm talking about, they were born with an average 3,000, 3,100 grams. And the early growth on these children is actually certainly very different from a cohort from Finland, where the average birth weight is about 3.5, maybe 3.6 kilos. So we can learn a lot from this. There are marked social disparities within our cohorts that we can also use to provide, to get better evidence on some of the associations. Our cohorts are growing under the epidemiological and the nutrition transition. So there's a lot of potential for mismatch. That is, somebody was stunted or had intrauterine growth retardation and then was exposed to a Western-style diet, did not get enough physical exercise, and gained weight very rapidly. So we can look at this mismatch in a very efficient way. Now, the third thing I'm going to talk to you about is the cohorts network. And we were invited to join one of the many Lancet series now that tend to appear every week, and Joy is an author in half of them. This is the Lancet Nutrition series in 2008. And I was asked to do a paper on the long-term consequences of undernutrition. And I said, I can't do a paper just with my cohort, so why don't I try to pool cohorts? And why do we pool cohorts? Well, there are a number of advantages. The most obvious one is that we get bigger sample sizes, but we also get more external validity if we find a similar finding in different parts of the world. The other thing that's often not appreciated is that we get less publication bias, because if each cohort is publishing their own studies, we all do that. You do an analysis, you don't find anything. Either you don't write it up, or you write it up and it gets rejected. So it may not see the light of day. So you get publication bias in which the studies with positive findings are published and the negative ones are not published. And we have taken this, when we set up the cohorts consortium, we said, let's publish everything for the 5 cohorts. Therefore, we often have mixed results. Maybe we find something in some of the cohorts, but not in the others, but everything gets published. And hopefully, keep our fingers crossed, it will have a higher impact in policy if we have a big study from 5 cohorts from 5 very different places in the world. So at that stage, I said, which are the big cohorts in the world? And then I read the literature again. I knew most of them already, but I said, let's take only cohorts that have follow-up from gestation or from birth. They have to be population-based. We don't want cohorts from a single hospital or clinic. They have to have at least 1,000 participants at the beginning, and they have to have follow-up for at least 15 years so that we can look at the effects. Let me go forward, and then I'll come back. And then we actually set up the cohorts group. And Joy is correct. We spent the whole first meeting trying to find out some acronym something that would spell out cohorts. And here it is, Consortium of Health-Orientated Research in Transitioning Societies. It's better than March, I think. Anyway, and by chance, these cohorts are from very different places in the world. We have Guatemala, Delhi, Cebu, Soweto, and Pelotas. Guatemala was an intervention study with 2 versus 2 villages, but it can be analyzed as a cohort study if you take care of the intervention statistically when you're analyzing the data. And these cohorts, they all have repeated visits in early life. They have social, environmental, demographic variables. They have anthropometry. There's a lot on feeding, on breastfeeding, on morbidity, mortality. And then they have very similar measures in young adults. Human capital, which is schooling, income, health-related behaviors, precursors for NCDs, body composition, blood pressure, glucose levels, so on, and reproductive behaviors. So they end up being quite similar. It was a lot of work to actually get our data sets into a single data set. We had to recode variables. We have to make sure that we were measuring the same things. And sometimes it didn't work. Some variables we wanted to study, we were unable to study because they had been measured in such different ways. Now, before I go on, I just want to show you one slide from another paper that we were involved in, which is not from the cohorts. This is a cross-section analysis as 54 DHS surveys, and we did that a few years ago. And this is like a growth chart, but I have flattened the growth chart, and the 0 line is this black line that you see on top at the value of 0. That is a child who would be the median child in that population. And then we plotted the average of these 54 studies against the standard. This is using the WHO growth standard. And we see that there's quite a lot of faltering, mainly in height up to about 24 months of age. This is relative faltering. They're getting farther from the median in terms of standard deviation units. Absolute faltering goes on a bit longer, but I'm focusing on relative faltering here, both height and weight. And after that, they grow more or less parallel to the standard. So this is a particular important period, which became eventually known as the 1,000 days, in which a lot is happening in terms of child nutrition. Then I'm going to show you 3 questions, and I'm going to show you what we found relative to these 3 questions. The first paper we did, we just looked at birth weight, we looked at IUGR, intrauterine growth restriction, and we looked at stunting at ages of 2 years and how these were associated with adult outcomes. This is the paper that came out of this. And we looked not only at biological outcomes. We didn't only look at blood pressure or glucose or overweight. We also looked at human capital. Because it's very hard to understand whether something that happened in early life has more benefits than does harm if you don't look at the whole picture. So you shouldn't only look at whether they're getting fat or they may have a slightly higher blood pressure, but you also have to look, are they reaching their biological potential? They achieve their height that they would have, they were biologically programmed to achieve? Have they achieved their schooling? How much money do they make? And what are their children like? What is the next generation like? So this is what is regarded as human capital. And this is the first time. At that stage, and this is also important, just want to tell you a short story. When you start a collaboration, people are a little bit uneasy. And at that stage, we say, everybody should give us their data and we will analyze everything. They say, oh, no, we want to analyze our own data. So we didn't share data in that early phase. We now have a common database. Everybody shares everything. But at first, there was this is one of the issues of cohorts. If you're building links, you have to trust. But trust doesn't come immediately. It has to be earned and developed. But this is a remarkable graph, I think. This is the most remarkable meta-analysis I ever saw in my life. And we all analyzed the variables in the same way with the same confounding variables. And it shows basically the following. This is the effect of height for age Z score at the age of 2 years on adult height. And if you look, this is males and females from the 5 cohorts. They're remarkably consistent. I've never, Tim is here, Tim Cole's here. He may have seen a better meta-analysis than this, more consistent, but this is really amazing. And it basically shows that if you are 1 standard deviation ahead at the age of 2, if you're less stunted, that is, you are 3.2 centimeters taller. And it just so happens that 1 standard deviation is exactly 3.2 centimeters at the age of 2. So basically saying that on average, that gap that develops in the first 2 years persists forever. In schooling, these are countries with different schooling systems. But we also found that if you're 1 standard deviation taller, you have 0.5 years of schooling more. And that's a lot because in those populations, some of the cohorts, the average schooling was 4 years, 5 years, 8 years in ours. It was really short. So half a year is quite a lot. And again, very, very consistent. Suggesting, therefore, that growth, that not being stunted in the first 2 years of life, makes a lifelong difference for your adult height. But obviously, things are changing. Latin America is changing very quickly. And so we're also worried about the other sides of the coin. So if you grow better, you're more intelligent, you're taller. But what about obesity? What about glucose? What about blood pressure? And we didn't find much in this. Look at that. This is points are all over the place. This is for glucose. We have very similar findings for blood pressure and for adult BMI. If you look at stunting at age 2, you don't really get any kind of consistent or strong association. But this is just looking at stunting at a given point in time. So our key messages from this study was that the intrauterine growth retardation, low birth weight, stunting had great advantages, had affected human capital very badly. So they had a permanent negative effect on human capital. But it also showed that there were no clear associations between body size and NCD precursors. We then moved on, and we got a second grant from the Wellcome Trust. I hadn't mentioned that. And we say, how does weight gain in different age ranges affect adult outcomes? And what are the risks associated with rapid weight gain? And there was a lot of literature from high-income countries showing that putting weight gain more rapidly in the first few years of life did a lot of bad things for you. And we said, is that true for our cohorts where a lot of kids are actually undernourished? And we use conditional weights, which is a way of taking into account the correlation between different weights. I don't have time here to discuss the method very detailed, but we did several papers. And I'm going to summarize this in a very simple way, maybe oversimplified way. And my colleagues at the cohort said, this is Cesar's cartoon, because it's not, we don't see data here. There are no confidence intervals. You know, it's just basically what we found is the following. Look at the blue line. The blue line are the good things, are human capital, height, schooling, and so on, and child survival. So if you put on weight or length, in this case we're studying weight gain, up to the age of about 2 or 4, you make gains in human capital. But if you put on weight later, let's see if this works. Is that working? Yeah. It doesn't really make that much difference. So the first 2 years of life is when it really improves human capital. And we got this interesting pattern here for chronic diseases, for high blood pressure, for fat mass, for glucose. We got that the later you put on weight, the worse it is. So this is where we said, okay, there's a point around here in which we really should be worrying about children putting on weight. But if they, in our cohorts, if they put on weight here, it's mostly going for the good things, not for the bad things. So we introduced a new concept that it's not only gaining weight, but different ages have different implications. And these are our key messages. The early weight gain is beneficial, and after 2 years of age doesn't really confer any advantages to human capital. And in terms of the risk factors, it's the other way around. Early weight gain doesn't do much harm, maybe a little bit for some outcomes, but overall it doesn't do much harm. And after 2 years, it really puts you in a much higher risk of adult disease. In the last paper we did, before I move to the next topic, is when we said, yeah, but look, if you're putting on weight, you can be putting on weight because you're just getting fat, you're not growing taller, but you can also be putting weight because you're growing taller. Oh, wow, 5 minutes, here we go. And therefore, very quickly, you said 30, and you started 5 minutes late. You should have shortened my introduction. Anyway, in a nutshell, this is what we had before, the graph on top, you've seen that. But if you look at weight gain, the relative weight gain to how much you are growing linearly, so relative weight gain to your height, you don't really get any advantages on the human capital, and after about 2 years, it really becomes bad for markers for chronic disease. And if you put on height, if you're linear growth, it's really good for the schooling, for the positive aspects, for adult height, but it really doesn't increase your risk factors for chronic disease. Of course, the million-dollar question, I'm sure Andrew is going to ask me that, is how do you make children grow in height without getting fat? And we have some hints, but we don't really know. So these are the key messages. No, different thing. Weight gain is one thing. Linear growth is something else. If we can disentangle them using all these fancy conditional regression methods that we use, you can actually get very good separation of the two things. So policy implication is very important. You really have to find out how to make these kids grow without getting fat. Now, my last section is what are we learning now? And I just want to focus on this graph here in the center because this is a ultrasound measurement. And the person who convinced us that we should measure not only carotid ultrasound, but also visceral fat and subcutaneous abdominal fat is sitting right here, John Yudkin. He came to Pelotas, and when he left, we went out and bought an ultrasound machine. So we actually have some really interesting results here. But before we talk about ultrasound, let's go back to intelligence. if you do a meta-analysis, and this one we just did for an article we're preparing right now, you look at all observational studies, even the good ones that controlled for all kinds of confounding factors, and they show that there is a 3 IQ point advantage of being breastfed for longer periods. So breastfeeding is associated with greater intelligence. There are postulated mechanisms, long-chain fatty acids, and so on. So there's a biological basis for that. And there are also 2 RCTs that show similar effects. So, but does this matter? Does 3 IQ point matter? And this is the point that we wanted to, and also, most of these studies are in children. They're not in adults. So does that difference last? And does it matter? And here what we have. We just did that with the 30-year. They spent like 40 minutes doing an IQ test. There was a very detailed assessment. These 3 graphs, they have breastfeeding duration from less than 1 month to more than 12 months. And this is IQ. Look at that, 4 points. And a pretty nice dose-response association. And this is schooling. Remember, these are kids who go to 8 years of schooling. And they have about 1 year more if they breastfeed for 1 year, adjusted for 11 confounding factors in a setting where there's no clear social patterning or breastfeeding. And look at income. Sure, if you fit a trend line here, there's a real association trend. It's a pretty big change in income, about 300 to 400 reais a month. That's quite a lot. Now, I'm a bit puzzled about this group. Look at that. They are more intelligent, the ones who breastfeed for 12 months or more. They have more schooling. They seem to make less money. And I know why. They must be academics. Anyway, if you see the linear trend here, it works well. We also did mediation analysis, using fancy techniques. And we said 75% of the effect of breastfeeding on income is mediated through IQ. So we have a pretty strong case here of actual true association. I know I'm running out of time, but I just want to present a couple results on visceral fat because this is so hard to measure. We measured this in 3,800 people. I think it's probably the biggest study with the ultrasound and separating visceral and subcutaneous fat. And again, we found a very similar thing. Remember the other? If you look at relative weight, you put weight later in life after maybe 4 years the risk starts, and then later, men and women, you get more visceral fat. It's not related to birth weight. It's just related to later growth. If you look at height, you don't get the association. So if you grow in height, but you're not getting fat, you don't get more visceral fat. And there's an interaction with IUGR. So if you have intrauterine growth retardation and you put on weight, you're really at a much higher risk. For women only, and this is one thing that maybe we can get back at something. A lot of these associations are sex-specific, not only in epidemiological research, but also in animal research. So we really need to understand much more why something seems to affect women in a different way than men. But anyway, here's the finding confirming our earlier studies in which we just looked at other outcomes. In this, we looked at visceral fat. And I want to finish by mentioning what are the constraints to cohorts in low and middle income countries. We have multiple health facilities, lots of home births in some places, so it's really difficult to recruit pregnancies and births in some places. We have 100% hospital births in Pelotas, but for antenatal care, they attend 50 different facilities, so 50. So right now we have one person in each facility recruiting people. You have to have very good strategies for locating subjects because they move around a lot, they change addresses, their addresses are not precise. How do we handle people who moved out? In our cohort, if they're in the same state, we pay them a bus ticket to go back to Pelotas, and they really like the idea, so they come and see their family and so on. But if they migrated out to other states or to other countries, very hard to get. Hard to get biological specimens in many low and middle income countries, not only to get them, but to process them and to maintain and store them. The issue of subsamples. I would strongly recommend anyone doing a cohort not to do anything on subsamples if you can avoid it, because then in the end, if you do subsamples at different times, people may not be in the same subsample, then your N gets really much smaller. How often do you visit them? If you visit them too often, they get tired and they refuse. If you visit them very sparsely, then you lose them because you haven't been in touch with them. It's a real tricky issue. How to maintain consistency in questionnaires. Knowledge changes, but you want to have consistency with previous definitions, so that's another big challenge. And last but not least, how to ensure sustained funding, because there's a real issue which is called donor fatigue. Donors may love you, they love your cohort, but after 10 years of funding, if you can get 10 years, they say, okay, it's now time to fund other groups. We have to move ahead, move to other different studies. And you had enough support from us. Even though you're really good, we want to move. And this is it. I think, just tried in a nutshell to give you an idea of the practicalities of doing these cohorts and some of the results that can potentially have huge implications on health policy. Thank you very much.
Absolutely fantastic. I bet there are hundreds of questions, thousands of compliments for his proliferation of 3D computers and changing them into more but smaller, and really thoughtful comments on the practicalities of doing this research as well as what's being learnt. But hold them, because having looked at the world, that map he showed of the births in the world and where there are big cohorts, I'm afraid we haven't got anyone from Finland, but we have got the top person for UK cohorts. So next up we have Professor Diana Kuh, who is the director of the MRC Centre for Lifelong Health and Ageing from UCL. She's the lead for the British 1946 cohort. And they started with 5,000 births in March of 1946, and they still have 86% follow-up in their late 60s. So this, to me, is fascinating, not just in the story of that life course through those people, but also the scientists. How does that work? How do people keep that going? How does that happen? And she is also, I think, a professor of acronyms, because she is the head of several different networks of cohorts, and one is called Halcyon, which is an even more interesting one than cohorts. And she's also, I think, a wonderful example of a woman at the top of the science tree who's also brought in teams and capacity. So she's someone I'm really looking forward to hearing from. So thank you, Di, and over to you.
Oh, thanks, Joy. Actually, while getting the slides, I'll just say there is actually so much in common here. And I think some of it will come out, not in a half, but much more will come out later, I think. So, stunting, I mean, we just wrote a paper. I mean, our 46 cohort, there was quite a lot of people who were stunted. They died earlier in adult life. You talked about the sort of rapid weight gain in the feed, breastfeeding, all those sorts of things. You talked about the punch cards. I think what's the fastest, just like the epidemiological transition is faster in the low income and middle income countries, we didn't get to imaging till 64 years after we started the cohort. So anyway, lots to compare. Okay, it's 6, yes, so I'll do my best to do. So thank you very much. The thing you didn't add was you only asked me 10 days ago or something.
14 days ago.
So I'm sorry if some of you have seen a few of these slides. I've tried to change them around a bit. And although I'm going to give some examples from the 46, I was asked to give the kind of UK perspective, so I've tried not to take out lots of my own slides. So I just really wanted to put the context that we have now, the life course perspective, because this is really about, it was called life course epidemiology, that's what I was asked to, and then aiming for 100 years of cohorts. So there's this broad interdisciplinary life course perspective on health, on development and ageing, which has really emerged in the 21st century. And there's been this explosion of life course research since the 90s. There's growing evidence, and you've been hearing some of it, that the social and biological factors across life influence later life health and disease risk. And I think it's, more and more we're beginning, and hopefully to see health and disease as they're dynamic processes, reflecting the ability of the organism, the individuals we study, to respond adaptively to environmental challenges. And I really like this little slide at the bottom that Peter Gluckman had in the Lancet a few years ago, showing how you're interested on various different timescales of how people can respond to the environment, from homeostasis, which is kind of in a few seconds or a few minutes or whatever, developmental plasticity, the whole kind of David Barker idea of, and Peter Gluckman's idea of adaptation as a fetus and in very early life, which has long-term consequences. And then obviously in this all now being set in an evolutionary context of, and so natural selection over generations is also part of that. So why is this? So I'm not going to talk much to this slide, but you can look at it while I'm saying the points I want to make. Because we are, the fact there's been this explosion is actually, you have to talk about the past in cohorts to talk about the future. Because if we hadn't collected, or if our predecessors hadn't collected the data years ago, we wouldn't have that data to look at now. And I recognize all the kinds of things you're talking about keeping cohorts going. And so I just put this here just to show that actually two key things on the left-hand side, that these epidemiological resources are fundamentally driven by both science and technology on the bottom here, and also, does this work? Yes. And also, in fact, if you're going right back to the 19th century, you've got, and still, the development of the nation state and the idea of national fitness and efficiency, and population health is good for society. So these are very strong. We sit in a building that's funded by, I don't know if it still is, but Rockefeller was hugely important. And all these resources that have built up over the years, and in the mid of the 20th century, we started to get these national birth cohort studies, and we started to get the adult cohort studies of chronic diseases. And there was quite a lot going on here in child health and development, because you're talking about a period of social medicine, a period in the early 20th century where public health, where it was the conventional wisdom that the health of the adult depended on the health of the child. Now, there wasn't that much empirical evidence. There was a bit. Critical periods in biological and behavioral sciences were already being looked at, particularly in animal studies. You had the fact that we had the General Registry's Office in 1814 meant that they could do early cohort analysis by this period, and some of that seemed to show that the childhood conditions was terribly important for your risk, a cohort's future risk of mortality rate. So this is where the 1946 cohort study came in. I'm just going to quickly refer to my notes to make sure I haven't missed the critical thing, because I'm changing it around. So in that period when there was this interest in early life, it was very much the worry about falling fertility, about very enduring social inequalities in health. The 46 cohort showed how pregnant mothers and young babies and the survival and their health had very, very striking social inequalities. Again, there was lots of people from London School of Hygiene that were showing that in the 1930s and 40s. And there were studies like Boyd-Orr cohort, the Carnegie study that was set up in the 30s. The fact that they were measuring IQ in all the Scottish in the Scottish school children. All these things were actually going to build up to become epidemiological resources later on. And so what we have, in fact, these are just some examples of some of the main UK birth cohort and historical cohort studies. So here's the Boyd-Orr cohort that was, Boyd-Orr, the Carnegie cohort was all about the impact on diet, on the health of children and their families, and they've now been revitalised. The Lothian and the Aberdeen cohorts were the ones where they had childhood IQ, and then were able to link to other aspects of their early life health as well, and then revitalise it. But they don't have the intermediate information. Here's the 1946. It's actually called the MRC National Survey of Health and Development, and we do try and keep it that because the study members really know it as the National Survey, or they call themselves the Douglas babies after James Douglas, the first director, because there only have been 3 to 4 directors, but 3 long-term directors. And then there were 58 and 70 cohorts that followed behind. Note there is actually this 20-year gap. It's something to do with politicians I will not mention in this room, and you can ask me afterwards. I have some very interesting stories about that. But Jean Golding said, tough on that, we're going to start a study in Avon, and ALSPAC came into being. And then there's been this sort of spate of cohort studies. These are just, in the 90s, there was a real spate of cohort studies, both new cohorts, but also this is when these cohorts were revitalized, in fact. So these are the kinds of resources we have to work with. So I think another thing that rings true for what you were saying, I kind of divide this sort of a history period into some feasts and famines. I'm not going to, I think the panel can think about the future, but there was a really relative feast, I would say, in the UK between 1946 and, say, 1970, when the last of the British national birth cohorts was set up. And that was to do both with study teams. They were interdisciplinary, they were dedicated, like Cesar. They introduced both social and biological. They brought in statistical expertise. They were responsive to social and policy concerns. I haven't got time to go into those. They maintained very high response rates. And a lot of this was, at the same time, there was this strong tradition still in social medicine. There were these development of pediatrics, child psychology, psychiatry, all supporting it. And there were regional-based studies. I mentioned some in that next bullet point. And also some studies abroad that actually based their model on what was going on in the UK cohort study. So a time of relative feast. Now, it seems quite a short time, but there was a time, I would say, a relative famine of these 15 years in particular, partly because of poor economy. There was no real life course perspective. These birth cohorts were set up, they were going from hand to mouth, a lot of them. There was not a lot of long-term planning. I think the National Survey, the MRC cohort, was very lucky to get funding from the Medical Research Council in 1962, which we've had since. And that has been enormously important for our cohort. The epidemiologists and the public health people were focusing on adult lifestyle and chronic disease at that point, so they weren't really very interested in childhood health. It looked like it was getting better. And the social and psychological scientists were actually arguing amongst themselves and questioning the whole concept of critical periods and value of cohort studies. So there was this Social Science Research Council review in the 60s, which was really quite set up the thinking they were going to be very negative to cohort studies, and in many ways they were. Lots of small studies, ungeneralizable. They collected all this longitudinal data and they didn't know how to analyze it. Note this quote from it: only the mediocre will accept the fact that they might want to collect the same kinds of data on the same individuals. I mean, it's bizarre, isn't it? Now we all want repeat data. Actually, the 46 and 58 it was an international review of what was going on, but they came out of it fairly unscathed because they had high response rates, still well over 80-90%, and they were good value for money. We've always, in a way, tried to keep our heads just below the parapet, and sometimes I think we've put our head out too far lately. So while that was going on, there was still this unconnected, scattered social literature, some very good stuff going on that we would call life course epidemiology now. So the 46 cohort, I'll call it that for ease today, but they were maturing into adults, and with some of the respiratory physicians, they started to look at respiratory outcomes in their 20s and linking it to their childhood chest illness, their occupational father, social class, exposure to air pollution very early in life, for example. There was follow-up of the Haggerston morbidity studies in the States, actually showing that those of poor relative weight, these were children in the 1930s, poor relative weight, who then grew up to get fat, ended up with what they called hypertensive disease. There was the Dutch hunger winter that Zena Stein and Mervyn Susser first followed up, and is now a very strong epidemiological resource for many outcomes. We had the idea that you needed to track from childhood the conventional adult risk factors, one example, the Bogalusa. We had those early ecological studies from the 1920s and 30s, cohorts linking to cardiovascular mortality 50 years later. But the big sort of push for us in the UK was the work of David Barker and his imaginative work on the fetal origins of adult disease. So the life course epidemiology was actually coined as a term in '97 when this book came out. And in there just very quickly, there were three stages, and I'm going to say what I think the fourth stage is. There were three stages. The first was really testing out. Nobody believed this initially. London epidemiologists, very suspicious. So we thought we would review the evidence. And the focus was very much on cardiometabolic and respiratory. And I'm not have time to tell you all these things, but the kinds of things, you know, the U-shape in the diabetes, finding that it's not, you know, it was both underweight, babies are underweight, but also babies are overweight, trouble at both ends of the spectrum, that the birth weight effects were not necessarily confounded by socioeconomic circumstances. We looked at interactions with later risk factors, and so on and so forth. And what it did at the time, and other people were doing this too, was to say, actually, if even there are sort of three broad models of chronic disease causation. So there was the fetal origins, and we were saying, hang on a minute, you need to think about postnatal life. The adult lifestyle model, we were saying, hang on a minute, you need to think about how those lifestyles get developed in childhood. And there was socioeconomic, sort of Michael Marmot type approach, and we were saying, hang on a minute, a lot of this may be linked to what was happening in their socio and economic environment in childhood. So what it did was not only highlight the contribution of the birth cohort studies and these historical cohort studies that began to be revitalized, but it actually also gave us an impetus for a whole new set of research, and that was incredibly important. So then we came to a sort of second phase where I would say it became more sort of mainstream life course epidemiology. This editorial in the IJE that Yoav and I wrote is something like the fourth highly cited paper, even beat George Davy Smith just for a few months, I think. And what it did was that we started, and other people started, just as you say, you need to broaden it out, look at a whole set of health outcomes, which different people did, and we tried to capture it in some of these series of books. There was increasing focus on functional change and on growth trajectories. We were beginning to develop more of a conceptual framework and our life course models and methods. But one of the big things there was people were beginning to do sort of evidence synthesis. The whole idea of systematic reviews and meta-analyses in epidemiology was then applied to this field, and which I think really kind of strengthened it. So for those of you who don't know, just to give you an idea, I mean, very simple, the diagram on the left, just showing how more and more we've become to study functional trajectories as a way of looking at health across life before chronic diseases are manifest. And the early life factors can affect your ability to, your sort of peak function. They can also potentially affect your rate of decline in later life. If you're talking about something like lung function or cognitive function or something like grip strength, for example, whereas adult risk factors are really impacting on your rate of decline. And then on the right, you can just see some of what now seem very out-of-date models. We had David Barker's critical period model, but then we had a set of accumulation models of different ways that exposures across life could add up to have some effect on a outcome, as we called it in later life. This is all, to me, now getting really out of date, and we're about to update it because, again, you don't really see in those models the dynamic interplay. We've got wonderful statistical help, and you know, there's some leading statisticians who have shown us how to model these properly and work out which accumulation model it is. But ultimately, I think the whole thing needs to be made more dynamic. And the whole natural extension of this was to study aging, sort of the functional change after maturity, with an aim to developing an integrated life course model of aging, and that's what we've been doing. So Halcyon actually stands for healthy aging across the life course. And what has come out of some of this, and I mean, as I say, it's not just us, it's people all over the world now pulling together these maturing birth cohorts and the aging cohorts to study this dynamic interplay. And we felt very early on there was a real need for a pragmatic definition of aging, particularly of healthy aging, and we like to divide it between what we call healthy biological aging, survival, delay of onset of chronic disease, and particularly this optimal functioning for the maximal period of time at the individual level. So we start with that, physical and cognitive capability, your grip strength, ability to stand on one leg, your cognition, your verbal memory, and such like. Those things generally decline with age, as opposed to other aspects of health and well-being, which actually often show U-shaped curves with age. So it's all very interesting, but I would just keep them separate, look at the interrelationships. But what we were also trying to do, I don't have time to do this here, it's in various publications, including that book, is to try and develop this model of aging where we can look at some of the more key underlying biological processes, begin to think about physiological resilience or compensation, and look at how, at the individual level, at the body system level, at the molecular and cellular level, the kind of interrelationships and ideas of resilience at these different levels. So I feel since 1985, I think the first of the Barker papers came out in 86, we managed to just about keep on when there was a change of directorship in the late 70s. There was a real period of uncertainty for us. And it was 1982 when we did our first big 36-year follow-up, which was starting really to go into measuring aging and functional measures. So I would, around this time, and it's because I think, you know, we now have these rich data archives, so we can test life course hypotheses. We obviously have to keep abreast and ahead of what needs to be done. We've managed to maintain the high response rates. We've got new cohorts beginning and historical cohorts revitalized. So Barker was, I think, a big catalyst. I think the fact there is this beginning integrative life course perspective is very important. We're adding value, as Cesar said, by lots of cross-cohort studies. I'll show you a couple of examples of that in a minute. And actually just remember all the technological and biological advances. I mean, that could, you know, a whole talk on that, but the World Wide Web was only established in 1989. I mean, it's an enormous shift. Data capture in the field, the development of omics technologies, you know, how we now integrate all that. Obviously, the growing concern about population aging was important. You can't hardly open now a strategic or policy document that doesn't take a life course perspective. Certainly until the last 5 years, the economy was better, so there was actually a lot of improved funding for existing cohorts and for new cohorts and for life course research. But you should never take any of this for granted, and that's why I'm going to give you the history, and that's why it's really interesting to hear yours. So then my next few slides, which I'm going to whiz through quickly, and I'm happy to talk to anybody, but just to give you an overview, because how can you know, what can you do in 10 minutes with all the things that we've done and our predecessors have done? So one of the first messages was, as we were going, and then sort of particularly in the 90s, childhood experience matters for a range of adult health outcomes. And this is what sort of very simplified. These are the kinds of outcomes we were able to look at. We did a big clinic data collection at 60 to 64, so we have imaging and all kinds of things. I'll show you one or two slides here. But lots of, we could find, even in this really messy data down in 1946 and in the 50s, and, you know, we measured height and weight, but they were all measured by thousands of health visitors, and, you know, these are not beautifully clean data. We still find, I mean, asking about developmental milestones, neurodevelopmental indicators, they are linked to later life health. And we were trying to find the sort of broad, if you like, underlying pathways here. Barker and others and the epigenetics is trying to find the sort of more biological pathways and how it's kind of embodied. So I think some of the key messages are, we tried also to think it isn't just very early life. So there have been two other areas that our cohort's been particularly key to show other sensitive periods. One's puberty and adolescence, and again, this is shown in lots of cohorts now and it's becoming quite the thing to study. And I've just picked out the pubertal weight gain, and I put how that's linked to a whole pile of different outcomes in adult life, including the measures we now have, for example, for kidney and thyroid dysfunction now. This was work done by Richard Silverwood at London School of Hygiene, you know, where he got these overweight profiles, people who gained, little kids who gained weight, you know, here was at puberty, they gained weight, and the ones who had been fat all the time, these are the people who had the risks of of these kinds of outcomes. But we also look at, and in here work by David Bown, who's in the audience, again showing the, this time in terms of fat mass, DEXA measured fat mass, and relating that to the gains in height. These are conditional period of weight gain, and showing that puberty is actually, again, this period is very important for fat mass, many years later. But then also looking at behavioral conduct disorders, in terms of life chances and mortality here. Stunting, there's enough kids in our cohort 46 that we have two types of kids who went into diabetes. We had the undernutrition kids. This was not a time of a lot of children were not well nourished then, and we also have the children who gained weight and ended up getting more diabetes, and so on and so forth. I don't have time to say any more. So how we link are just a few, just some examples. Now, this is about the midlife transition. So we have very detailed data about the menopause transition in the women. So what this kind of cohort study can do, it showed more than any other cohort how many early life factors actually affect timing of menopause, and also adult factors. But then you could show, at this point, we only just have got these data now. If you just take, for example, women at menopause are supposed to suffer cognitively, that menopause affects your cognitive function. You allow for their prior cognitive function, those effects you see really go away. And now what we're looking at is actually what are the long-term effects of menopause transition and these early life factors on these various kinds of aging phenotypes. Another example, this is work by Rebecca Hardy with many other people linked with it. We were the first to show our cohort that low birth weight babies had higher blood pressure in 1985, actually before David Barker did that. But I don't know, but he was the one who really drew out what it might be about. And just the last few things we've done with this is to actually look at the change in blood pressure in midlife. So here's a group who are going up moderately, there are more people in this group, and there is a group with accelerated increase in blood pressure. And Andrew Wills with Rebecca, these are just some of them. They looked at the kind of factors right from birth weight all the way through to your health behaviours in adult life as to whether you were in which of these groups. So the low birth weight babies were more likely to be in this group, for example, and the poor socio-economic circumstances were also more likely to be in this group. And then some of the things you would expect, the sort of BMI kind of measures. What is now interesting, so we've got that link into midlife, and then we did measures, imaging of cardiac structure and function at the clinic at 60 to 64. And so I would say, here's another example of midlife as a sensitive period. We found that, again, similar kind of conditional models that you were showing, that the difference in left ventricular mass index and in other measures of of cardiac function, that this increase, this accelerated increase in blood pressure, was actually important for these measures 10 or more years later. Oh, do I just close this? I haven't got time to waste. Right, okay. So the other thing we've been doing, and I should have said all the way along there that while we were doing those, the kinds of examples I've given you, we were also doing a lot of work with others to replicate, to do systematic reviews, to build up so that it's stronger evidence for these associations we were finding. And I apologize for that. There are lots of consortia that I was going to mention as we went. Combining cohorts here is really important if you want to look at a whole lifetime trajectory, because not even in the UK do we have a cohort that's measured blood pressure all through life. We didn't do that in the childhood years. So again, this is work by Andrew and Rebecca and many others across the 8 cohorts to look where there was longitudinal data to get some idea of the rapid growth in adolescence, the smoothing, the shallower increase in early adulthood, this increase in midlife we were just talking about, and then potentially a dropping off in later life, although that's for discussion. And here's the Whitehall cohort suggesting an occupational cohort that suggests what we could be doing, as opposed to what is actually happening in the more nationally representative cohorts. I thought I'd put in work by Annie Britton that's just been put in BMC Medicine in Press. So it's not just, so we've been looking at blood pressure and with others we've been looking at BMI trajectories. Annie's been looking at trajectories of alcohol consumption in 9 UK cohorts. Again, I mean, showing this, you have to read her paper, but showing this peak in men's consumption at about 32 and then maintaining and then kind of dropping off and a slightly lower peak in women. But these are the sorts, and I'm just trying to give you examples of the sorts of things that now people are getting up to in a much cleverer way than I could possibly do it. Just my example on aging, I've got just 5 minutes, so was to take the one that Rachel and I particularly have been working on, that at the age of 53 I had luck to meet a physiologist and started to bring in measures of grip strength and chair rises and standing balance, what we call physical capability, which allowed us to look both at, again, early life. There's both a growth story, there's also a neurodevelopment story on these measures at 53, and I just thought this was nice that you showed your slide, because this is weight gain at different ages up until sort of what I call pre-puberty weight gain. And for the men, positive weight gain, I mean, having weight gain was positive for these measures of physical capability. Weight gain from puberty onwards was negative. And things like grip strength, you actually get a birth weight effect too. Because in this cohort, weight gain for this cohort in the pre-puberty stage probably was actually, particularly for the men, putting on quite a lot of lean mass. And that's what's probably showing up here. And then looking to see how measures at 53, these kinds of measures, do you see that when I do that? You do? Okay. Sorry, I'm a bit of a technophobe. So these measures had mostly been done in really older people, and so bringing them back to 53, you can start to see, well, actually, these are the people who are unable to do the test at all. This is all the tests look like this, but this is standing balance time. Here are the people with the worst standing balance at 53, and this is their mortality over a 13-year period. So this has come along with lots of systematic reviews through Halcyon cross-cohort studies, which, and here's one, I pulled this one out as an example because I think it may have Pelotas on it, that Rachel did, to show the differences in here. I'm using walking speed, that people from poorer childhood circumstances had slower walking speed across a whole range of cohorts. I want to go on just my last couple of slides. So this is doing grip strength and the function. So my last 3 slides, which I hope I'll be allowed to do, sort of thinking about the future and our current research. So more and more, I would say, the questions that are driving life course epidemiology now, and I'm very grateful to people like Debbie Lawler and Rebecca Hardy and others who did chapters for our recent book that really kind of brought this out. We really want to go, how do human systems and function change and covary across life? We actually know very little, and even the data we do have, we don't analyse it properly. We want to see it at these different levels. We want to look at gender and ethnic differences. We want to look at which periods of life do you observe important changes. We want to look at the lifetime determinants of level, but also of change, and those are the new papers beginning to come out much more now in this area, because the early life often predicts level, 36-year blood pressure, birth weight, but it doesn't necessarily produce the change in blood pressure. For some things we are finding it does also predict change. And what's the relationship between these measures of function across life and then subsequent disease, disability, frailty, and well-being? I'm not even going to mention the translational agenda, but obviously this is really important in terms of when you intervene. And I think we may get onto this in the panel, but I think I want to make this point about the big data. We've talked about combining data from multiple cohorts for power and replication, for improving causal inference. Obviously, genetic epidemiology has been putting cohorts together for a long time now, and there are some very nice things that birth cohorts and very long-term studies can do, as well as just the straightforward genetic associations, showing how genetic associations change across life, using Mendelian randomization to actually identify environmental determinants. You know all this. bringing in systems, what I'm going to call here systems biology, this is only really beginning in terms of can it give us more, the metabolomics, the epigenomics, can it give us more understanding of biological mechanisms, can it predict disease development or functional change? And, many people are doing this because they're actually wanting to find suitable targets for drug intervention. And these cohort studies are particularly valuable, particularly, for example, in looking for epigenetic changes, but not just the cohorts themselves, but also the life course methodological tools and models that we've been building up. And I think what I just wanted to say here, maybe in the initial genetic papers, you could put in almost any phenotype into those models. But now, just like you say, it takes time to do data harmonization to really build up those phenotypes. And actually, we need to better characterize these function, disease, behavior, lifetime exposures. And I thought it was wonderful, some of the modern equipment you were showing being cost-effective, minimally invasive devices. We really need to share information about that and get that in. Because what we're trying to do is capture intensity, variability, and again, back to the sort of dynamic interplay. And it all sounds very easy, but actually it's very hard to do. So we're aiming for a century of UK cohort studies. We hope to be the first cradle-to-grave birth cohort study. We're on to our 24th follow-up now. I'm right in the middle of it with my team. We're also doing clinical sub-studies, a big neuroimaging study which is about to start. So I don't have time to go through all those, but just to show you where 5870 are now planning new biomedical follow-ups to match with all their lovely wealth of social and neuropsychological data. And then the birth cohort studies, I think there's a big argument about, how big a scale they have to be, but these later studies, they were larger in scale, some of them had much more ethnic diversity. They've been able to collect much richer data in pregnancy in the first few years of life and also focus much more on intergenerational mechanisms. And so I'm going to end with just two adverts. One is that this has just come out in the IJE, a special themed issue of Life Course Approach to Aging. I'd like to encourage you all to put in papers for that. And then lastly, I'd like to encourage you all to come to a Wellcome Trust course called Maximising the Use of Longitudinal Studies for Aging Research, which will take place in July this year. And there'll be opportunities to put in for abstracts. I think it is now open. It's been a bit late coming because of illness and various things. And some of the things I've talked about today will be taken up in that meeting. So thank you very much.
Thank you, Di. She talked about feast and famine, and I think she got through a huge feast in a short amount of time with a great deal of richness. Not just in the findings and the implications, but also in the history, looking back to where these started and the focus and the learning over time. So I'm going to invite the four of you, please, to come and sit down. And what we're going to do now, before we open it up to the floor for discussion and questions, is to have two quick snapshots from additional experts. So we've got Professor Neil Pearce and Professor Andrew Prentice joining us here. And I'm going to actually start with Neil Pearce. So he's the director of the Non-Communicable Diseases Centre here at the London School. He's also the head of the Med Stats department. And he's got more than 30 years of experience on the chronic diseases, particularly in longitudinal studies of asthma. When you hear from him, you will instantly realise he's from New Zealand. What you may not instantly realise is that he's also an important member of a band called The Symptoms that have just launched their first album last month, so you can speak to him about that over wine. So moving back to Life Course Epi, Neil, we've heard about this almost a century, or aiming for a century of cohort studies from high-income countries, about 30 years, from middle-income countries in transition. And what does this mean for implications for prevention and control of non-communicable diseases?
Okay, thanks, Joy. And I'd like to thank Joy and the Match Centre for inviting us to be co-organiser of this, and also to Lizzie, who does the admin jointly for the Match Centre and for the Global NCD Centre. The Global NCD Centre our whole field is an acronym, which none of us can pronounce non-communicable disease very quickly. So our acronym is built in. I've been sitting here desperately trying to think of something to say, and I'm glad that the speakers have all run a little bit over time, because probably my 5 minutes are up already. But I'll make 3 points and then hand over to Andrew, and then we can have a discussion and have some drinks. 3 things I'd comment on. Firstly, I think what you've seen shows why we need global studies. We can't just do studies in the UK. The cohort studies in the UK are fantastic. We need more of them, but we need more and more. We need 50 studies like Cesar's in 50 different countries around the world. They are not only important in themselves, but they help us interpret what we see in the UK. The fact that, for example, we find smoking and lung cancer the same association everywhere in the world adds to our belief that it's a causal association. The fact that you find the same things for breastfeeding in Allspac and in Pelotas reassure us that it's not due to confounding. But there's other things that differ around the world. I helped organise an asthma study in 300 centres in 100 countries called ISAC, and there you find the dogma in the UK is that asthma is an allergic disease. It's not true in low and middle income countries, and that's really important to discover that, because it helps us reinterpret what we see in the UK. So this constant interplay between what we see in different countries, different populations, different confounding structures, different ethnic groups, which is not very well covered in UK cohorts, except perhaps born in Bradford. Doing these studies in different populations is really, really important. And a major problem is there's no one to fund them. There's different funding bodies that will fund something in Brazil and something in India, but there's no one who will fund global studies. And we really need 50 identical birth cohort studies in different parts of the world. The second thing I'd like to comment on in terms of research is the idea of critical periods. And I think it's really important, but it's going to differ for different exposures and different diseases. I think the whole life course concept means the whole life course is important, and it's really good that all the different aspects of the life course are being addressed. Maybe the pendulum swung a little too far, and middle age is not getting the same attention perhaps in cohorts overall as it could have, but basically we cover all of them. But it's important to recognise that different periods will be important for different things. There's some things like smoking and lung cancer, occupational disease, where the exposures themselves are almost entirely during, standard adult period. In terms of critical periods, in terms of etiology, it differs with the disease. For example, if you get infected with hepatitis B before age 1, you're going to become a carrier. It's 95% certain. If you get infected as an adult, it's very unlikely. So there's a clear critical period. For something like asthma, it's not so clear. The dogma is that the first few years of life are important, but in fact, if someone changes country or starts a new job, or their environment changes, which we found in a study in Poland, that after they joined the EU, people got rid of all their animals, and then they started getting more asthma and allergy. And that can happen at any age. So it may be that the first few years of exposure are crucial, more so than the first few years of life for many of these exposures. Another example would be cognitive function, where clearly we can do things in middle age and older life to affect that. There's a course I teach here on study design, and one of the groups last year had to design a study of interventions for Londoners aged more than 60 years to delay the onset of dementia. And they came up with lawn bowls, bridge, ballroom dancing. So I explained that I was 61 and we did things like run marathons and play in rock bands, and it took a little time to explain to them that 60-year-olds were not actually out the door yet. So those critical periods are really important. Finally, in terms of policy, politicians want an easy answer because fixing up all of society is too hard. In research, we recognise that for some exposures, some diseases, certain time periods are crucial. So early life is crucial for some things, old age are crucial for some things. But what politicians tend to want to do is we'll do something for the kids and we'll do something for the old people, like with the heating bills, and in between you're on your own. And the problem is people don't live like that. For example, in New Zealand, you have to pay to go and see the GP, and they brought in a policy where children under 6 would get free GP care, and they found that parents weren't taking it up. And the simple reason was that the parents still owed money to the doctor from their last visit, so they wouldn't take the children along for the free visit. And there's a lot of things you can do for children which don't work very well because they're living in families. And ultimately, the best way to have less inequality in health is to have less inequality in society. And therefore, we need a life course approach to policy, even if we give particular focus to particular age periods for particular things. But we need to look across the whole life course in policy, just as we're doing in research. Thanks.
Thank you, Neil. If you're nice to him, he'll maybe play his rock band single afterwards when we have wine. And finally, and definitely not least, Andrew Prentice. So more than 30 years of major contributions, especially through fieldwork in the Gambia. So we've heard middle-income countries, we've heard high-income countries. The big gap here is low income, nothing. So for those of you who are looking for something to do for your next 50 years, cohorts in low-income countries and how you're going to persuade people to fund those as well. And Andrew, you know, we've heard a lot about the epidemiology. We've also heard about the increasing biological samples and much more complex measures of status as we have seen the progression of these cohorts. Out of this and out of the epidemiological life course study, what are the seeds that are coming for the epigenetics side?
Thanks, Joy. I don't know where to start almost, because first of all, but I think it's very important, because I'm going to stir it up a bit, I'm going to shake it up a bit. This is far too comfortable. So before I do that, for those of you who don't know me, know that this is the typical trick of mine, and it's very much in the devil's advocate mode. So I'm, you know, enormously in favour of cohort studies and life course studies. So please understand that clearly before I do a little bit of shaking now. So the shaking I want to do is, and it relates to things that have been mentioned already, which is how do we keep the funding for these things going? So my own work in the Gambia, how do we keep that funding going? How do you guys keep that funding going? And how do we share the limited pot of funding between ourselves? Because to a certain, I mean, I don't do life course stuff. We have a certain amount of that, but they're not classic cohorts. But I sit on various funding committees where I increasingly see that despite Di's description that there's been some wonderful funding come forth and the life study, etc., that there is a competition for funds and how do we keep it going? And in order to make that case, we've really got to show productivity, and productivity in terms of translation. So, Di, just towards the end of your talk, you said you all know about the translational agenda. I'm not going to talk about that or something similar. I haven't got time. You haven't got time about the translational agenda. That would be a whole thing. Yeah, but I think we do need to push ourselves and ask ourselves the question, okay, we've got all this wonderful stuff. Some people, mostly people not in this room, but would be very skeptical and say, but there's confounding, etc. What about causal pathways? What about causality? And most importantly, how are we going to intervene and do the really robust randomized controlled trials at certain times in the life course? And you, Cesar, mentioned, you know, how are we going to get children to grow linearly without adding fat? You know, these are the next challenges. And I think that it's building in the biological mechanisms, which you also talked about in your penultimate slide, Di, that is really going to get us there, because the life course work shows us where critical periods are. It shows us what are the critical dimensions of growth, anthropometric change, etc., that we know are associated with poor outcomes. But we're really going to be increasingly challenged, I think, in this field to say, okay, great, you've shown us this, but so what? Where does that take us next in terms of public health interventions that are really going to make a difference? And it's not really me giving you that challenge. I mean, I hope you might take a few moments to to try and bring out some examples for the audience as to where we can get those hits. Actually, I'll give you one great one before I stop, even to help you with your starter. You know, we're going to have to do that, and I hear on the funding committees I sit, that's a constant challenge. And there was one group of cohorts which got funding by the skin of their teeth recently, and I had to fight for them in order to get that. So this challenging is going to come time and time again. Now let me give that one example maybe of where I think the epidemiological research could lead us forward in a very important way. It wasn't in itself a life course study at all, but it's intimately related to life course. So the example I'd give you would be the work of Smithles in the 1970s, early 70s, showing that there is an association between vitamin deficiencies in mums during pregnancy and neural tube defects. Simple epidemiological observation, taken forward into randomized controlled trials, and leads us to the best life course intervention, or the most robustly evidence-based life course intervention we have in nutrition, which is prenatal folic acid reduces neural tube defects. You know, there are many people in this room that might have had a neural tube, well, not many because we haven't got a big enough audience, but in principle, there are people alive today that would have had a neural tube defect had their mums not taken folic acid. It's a marvelous intervention. We know it's robust. We need to find examples like that where we can show what that kind of causal linkage is. And of course, I'm a great fan of the epigenetics at the moment, and I think we can do that, and I'm speaking with the life study about that. But I think we've really got to try and move forward pretty rapidly to that state. Otherwise, we're going to have increasing difficulty in keeping the funding in place for these wonderful life course studies.
So thank you, Andrew. I think he's opening a moment for also maybe others in the audience who want to throw in their questions or their queries, their thoughts on this. We've got some runners with mics. We've got time for a few questions if people... Oh, so stunned.
Silence.
So much feast that can't be taken in. Okay, well,
Let me come back in, Joy, then, if I can. If no one
well,
else...
maybe they can answer your question.
Might.
Would they like to respond?
No, you guys have asked for it, though. You're going to have more of me if you don't talk. I mean, the epigenetics, I think, gives us a fantastic window into this, because what we're seeking for there is a measurable pathway by which these associations can be entrained. Because if we know, we know that things that have happened very early are having an effect 60 years later. We have to understand, how can that be? What is the messenger that has allowed those links to occur? That must be written in some physical form within the human body. We have to, there's got to be a mechanism. Now, some of that is anatomical. It's because you've got fewer renal tubules or whatever. Some of that will be anatomical, but others will not be anatomical at all. But it'll be written into the cellular biology of the people. And I think we're getting at a stage where we can now try to measure that. And that's what we need to do, because then that gives us also the option that those things are modifiable. The maternal diet at the time of conception can alter the epigenetic imprint. And this, indeed, to give you another advertisement, is what we're going to talk about in the next of these series in May. But I really think we can reach that linkage, and we need to work hard as a team to do that.
Okay, so maybe what we could do is, for the members of the panel, if some of you maybe want to take some response to that, but also to give us your final thoughts on what next. So we've got a younger generation here of upcoming epidemiologists who will go back. They'll be the next Cesars, went back to Pelotas. You'll go back to where you're going to go back to. What's the next big thing? So some answer to Andrew and the next big thing.
Maybe I'll jump in and then leave Di and Cesar to do the concluding remarks. Since you were keen to stir things up, maybe I can do that a little too, because I'm old enough to remember genetics, epigenetics, metabolomics, now it's the human microbiome, and now we're imaging everyone. And with each sort of generation, we learn a bit, but it's a bit like England football. You know, there's the huge anticipation, huge hype, and then the inevitable disappointment, and then
toys for the boys.
yeah, and then 4 years later, people forget what happened last time, and they get all enthusiastic all over again. And the epigenetics is going to be the same. It's going to be useful for some things, but not as much as we thought. It's just going to be one more bit of the toolkit. It's not going to explain everything. So that'll be good, but wait 5 or 10 years, and then it will have been useful for a few things, but we're still going to learn most of what we want from plain old-fashioned questionnaires, and that's how you discover there's something, and then you can use that to discover the mechanism. So I think we should use the new technology, but not put all our money into it, get it into perspective, and we need more cohorts in the UK, but we need more cohorts elsewhere in the world, and that will help us to learn a lot more about the UK as well.
Although I find it intellectually interesting, the epigenetics, I also have the same concerns as Neil here. And it is the next big thing, just as the metabolomics are, and we're putting a lot of money and a lot of time into that. And if you think about back over time, the public health benefits, the biggest public health benefits, we didn't necessarily understand the mechanisms before. It was absolutely obvious that children need to be cared for and reasonably well fed to have a chance of to have good life chances later on. I can't, 2 minutes, I can't respond to all the things, but I would say 2 obvious things from the work we've been doing. One is time and time again we see duration of overweight being having a really big impact on lots of outcomes. We also know that duration, that once you become overweight, it's really difficult as individuals to lose it, especially in this kind of environment. And therefore, the kinds of intervention studies, I think we could, and people are already doing this, there are things which we can actually try and help to improve so that people either don't get overweight in the first instance or certainly don't wait until they're sort of in their midlife before you're expecting them to lose weight. So those things all the time. I think I'll pick a midlife example because, I think there are some early life examples, but I think the midlife example with physical capability is really important because we all start physically declining from our about 30s on most of the things that I look at. Even though Neil runs marathons, there are people like me who can't run marathons. I've already got NEOA. If you go, nobody knows what to do, well, very few people know what to do with sort of functional decline at a very early stage to stop progression. You need to unpack in the sort of public health box and the whole sort of rehabilitation box. You need to unpack what we can do at much earlier stages so people don't reach the stage when the NHS will now only see you are you walking with a stick yet? So there's lots you can do, and the kind of data that Rachel's publishing now, a lot showing that those midlife measures really matter for your quality of life and your health in later life. So I would just go for those 2. So we are working with people to try and actually move those sorts of things. Obviously, we still need more evidence. We still need to know the prognostic value for individuals of some of these things, but they are beginning to be brought in to assessments much earlier on, and maybe being able to identify, if you like, vulnerable groups who may have a very fast decline. So I have examples in early life, but there isn't time for that. As far as one of the things, the next thing I've got a bugbear about at the moment is capacity building for people willing to take on and really spend time building up these cohorts and making sure they're maintained. We do huge amounts of data sharing, and that's that's fantastic, and we do lots of pooling. But ultimately, we need people who will actually put time and investment in to really kind of keep those cohorts going, and that's becoming, I feel, less and less for people an attractive option because of all the other kinds of research that's going on. And I think we really do need to address it and show how much actually fun it is to do. I've had a lovely 30 years doing it. And I think those kinds of training programs need to be out there. We don't just need to know how to model life course data, we need to know how to collect bloody good life course data. And, you need to get your hands dirty if you're in this field.
And finally, Cesar.
Okay, I'm thinking about the life course of a scientist. We start as curious kids who, poke at things and do all sorts of things. And then we go to school, we're good students. And we learn a lot. And we graduate, and then we start publishing, discovering and publishing. And if we don't perish because we don't publish, we get into old age like Neil and myself. And then we start worrying about dissemination and policy. It's almost like a life cycle, because we think, I'm running out of time, so I just want my findings to be turned into something useful. And I have this story about I was in a PhD Viva exam in Groningen in Holland, and it was a thesis about breastfeeding composition and child health. Breast milk composition, child health, and these guys were really hardcore biologists, and then we went out. I talked about it and I explained what I thought about the thesis, gave some examples, and then at the end we went out for dinner and we're having a drink, and this biologist came to me and he said, "Cesar, don't you get tired of never being able to explain anything?" I mean, you're just finding associations. You never really explain anything. And I said, well, that's what happens when you're an epidemiologist. You can't explain it. I'm just I'm just joking here with Andrew. But actually, you can't have policy without knowing everything, the exact mechanism. If you have strong enough epidemiological evidence. And obviously we want to know. We want to know more. We want to know what changes that makes an old person be influenced by something in early childhood. But I just want to wrap up with a concrete example. One of the things we're doing, I see Liz is sitting here. Liz was head of WHO maternal, child, and adolescent health. And when we came out with these results that putting on weight rapidly at certain ages was okay in low and middle income countries, but after a certain age it could be dangerous. And the guidelines from WHO actually, if you get a 4-year-old who has low weight for age, but also short, they try to increase their weight. They give all sorts of fattening foods to make that kid heavier. And they don't discriminate between linear growth and weight gain. And so they're now, she called a committee of experts that was part of that, and now they're really reformulating all their guidelines for child growth based on results such as the ones I showed you earlier today. So I think this is a real challenge, and I think that's when I get really happy for my work, is when something practical happens as a consequence of what I did. So those 30 years of doing field work paid off, not because of the papers, but because something changed in real life.
Thank you so much. Okay, and now to wine, but just our thank yous first. So first of all, thank you to the speakers. I think especially the two main speakers gave us a huge feast, so thank you. And I think one of the things we learned was we've had 90 minutes. We probably could have 90 hours on this topic. I mean, the richness of the discussions on many different dimensions and many important areas. We talked about critical periods, and within this adolescence as a critical period, we just had a very short slot on that. And now that both birth cohorts are moving back to starting during pregnancy, we haven't had anything maybe on the stillbirth loss or other parts that are also critical. So I think absolutely fantastic. Secondly, thank you to the hosting partners. Thank you to the NCDs Centre, to the MRC Centre at UCL, and particular thanks to Lizzie from both our teams here, who's done a lot of running around. And then finally, thanks to all of you. I know as I look around the room here, there are people who have published many of the papers that have been cited, or have changed the policies that those papers referred to, or have funded the work. And that is fantastic and important. So I hope that over wine we can continue those discussions. And as you can tell, the one that happens in May is going to be hot and exciting. Andrew is not just going to give you the simple things. It's going to be really worth coming to. So come back for that and come and enjoy the wine. And thank you once again.